So we're going to begin Chapter 7 now, and Chapter 7 deals with a lot of applications, business applications, essentially associated with percents. So I want to recall some of the material we covered already and how we work percents. So recall we would usually write a question. What is 6% of 500? So in section 1 of chapter 7 here, we're going to deal with applications that utilize essentially this question. Now remember how I said a good way to do this. Whenever you see an of, you put in a time sign. We can bring our numbers down. 6% we have to turn into a decimal, 0.06. Anytime you see is equals, and what, that's a variable, x. So we're just writing a simple algebraic formula, x equals 0.06 times 500. So what is 6% of 500? Well, the answer is 30. So we're going to use these type of ideas in business applications. And the first thing we're going to talk about is, say, a discount, like a sale at the store, a discount. So I'm just going to jump right in and ask the question. So say a certain item is on discount of 25%, so it's like 25% off. And the original price is $500. Let's say $500. What is our discount? Or how much do we save? Could ask the question in both those ways. Well, let's set this up the same way we set up the equations before. What I'm asking here is what? 25% of $500 is what? Is equal to what? Or 0.25 times 500 equals x. Well, here, if you do the math here, your discount turns out to be $125. So we can go a step further and we can ask, what is the sale price? Well, if this thing is being sold at $125 off, then our sale price, original price, starts at $500. So there's our original. And we subtract off the sales price. Or we subtract off the discount, I should say, not the sales price. And we end up with $375. And that is our sales price. Now, we could have done this whole thing another way. So, if this thing is 20% off, then it's selling logically at 80% of its original price. Well, here, 80 and 20 are complements of each other. That is, if you take them, you're going to always end up with two complements when you add them together, always end up with 100%. And in our example above, actually, let's use the numbers from above here so we can rerun. Well, I'll leave this 20 and 80% here. So in the above situation, we have 25%. Then the complement of that is 75%. So if you can recognize what the complement is, you can skip the step of calculating the discount and then subtracting from the original price and just do it all in one step. So you could do essentially this question, 75% of, what was our original 500? Of 500 is what? So 0.75 times 500 equals, and you see here for my calculations, equals, my calculator, equals 375. Just like it did above. So you get the same exact answer. Here's a couple more examples of complements. 10% and 90%. You add these together, you get 100%, 15% and 85%, and 92% and 8%. So any two numbers that if you add together, you get 100% are complements of each other. Okay, just like we did before, we can use algebra to work these problems in reverse. So, for example, so here, if the sale price is $2,288, and this was marked down from $3,520, what is our discount percent? Maybe you're working in a store and you want to write a sign what the percent of discount is for customers. Well, let's solve this the same way we did before. We want to know here let's figure out, well, there's a couple ways we could do this. But let's say we're going to do it, let's do it this way. Let's figure out what percent, so we don't know what this is, what percent of 3520 is 2288. So 2288 is what percent of 3520? And you'll see why I'm doing it this way. Okay, so this is, if we turn this into an equation, this is like x times 3520 equals 2288. If you always do these equations like this, you'll be less likely to get confused and accidentally divide or multiply when you shouldn't. So in this case, x equals 2288 over 3520. And as we can see here, this is going to be a number smaller than 1. And that's because, that makes sense, because this number, 2288, is smaller than 3520. So it's less than 100% of 3520. So it's a percentage of it. Anyways, if I do the math here, I get 0.65 or 65%. So 2288 is 65% of 3520. So now we know that 2288 is 65% of 3520. That's not answering the question, though. The question is, what is our discount percent? But we know that that is going to be, from experience that we've taken, that 65% is going to, the complement of it will be our discount. So at this point, we could just write it down then. Our discount is 100 minus 65 equals 35 or 35%. So you might be thinking that's not the only way I could have solved this problem. So let's show you a different way. First, we could find what our discount is. 3520 minus 2288 equals, this equals 1232, $1,232. This is our discount. So now we can ask the question, 1232 is what percent of our original number, 3520. So now when we turn that into an equation, we're essentially solving this equation. 1232 equals X percent times 3520. And we see here, to solve for X, we need to take 1232 and divide it by 3520. Here you can see I did this on the calculator. And it equals the same number, 0.35. So, two different ways to solve these sorts of problems.